Hello everyone, I'm Bhagyashree Pradhan, your one of the TAs for this Drug Delivery Principles and Engineering course, and welcome to the first session of Drug Delivery Principles and Engineering. So let's start. Let's start with the assignments straight away. Have you guys gone through? Oh, sorry. I'm so sorry, my mic was off. Hello everyone, I'm Bhagyashree Pradhan, one of your TAs for this course, Drug Delivery Principles and Engineering. Welcome to the first TA session of this course. Okay, have you guys gone through last year's this week's lecture, all the lectures? Hello? Hello? Yes, ma'am. Okay.
Ma'am.
I'm audible, right?
Yes, ma'am.
Okay. Good. Okay, let's straight away go to the assignments. So today we'll discuss previous year assignments for this course and some of the questions you might expect at the end of the course in the exam. Okay. So uh, okay, I can you guys let me know if you all went through all the lectures for this week or just few lectures you have completed? Like I want to know what is the status of different people. Hello? Just week one, a few. Okay. 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 So, but the questions will involve all the uh, lectures that was taught this week. So, if you guys have any doubt, you can stop me and we can discuss regarding those. Okay. Okay. So, I'll share my screen now. Is the screen visible? Hello?
Yes, ma'am.
Okay.
Yes, madam. Screen is visible.
Okay. Are you guys able to see the question? Is it legible?
Full screen mode will be better, madam.
Okay. Yeah. Can you guys all see the question now?
Yes, ma'am.
Okay. So, This is the first question. Which two statements are true for pharmacokinetics? Uh, can you guys raise your hands if anybody wants to go ahead and try? Just a second. Anyone wants to try?
Yes, madam.
Yes, please go ahead.
Uh,
I'm sorry.
yeah, one
You guys can
statement.
already see the answer, I guess. Okay, still.
Oh, the answer is there. Oh, below. Yes, yes, madam. Answer is below. Yes.
I'm so sorry. Okay, yeah, go ahead.
Yeah, I was going to say how drugs are absorbed or metabolized. So there's one more.
Yes.
So the
The
answer is
question
already
itself
there.
says no,
Answer
there
is
are two
already
statements that are true for pharma. Which two statements? So you have to select two.
determining dosage regimens.
Yes, correct.
Yeah.
So
So the answer is already there.
this was a straight giveaway. Okay.
Yeah.
We'll move on to the next. Does anyone have any doubt in this question?
No, ma'am.
It's pretty straightforward. It helps us study determining the dosage and drugs that are metabolized throughout the body. How drugs are metabolized throughout the body. Okay, this is the second question. Aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of solubilities at pH 6. Anybody wants to try? If anyone wants to speak, you can just unmute yourself and speak because I have to unshare my screen to see who else
Madam,
has.
madam, the answer is already there.
You guys can see the answer.
Yes, madam.
Okay. Even in full screen. Okay. Okay, guys, just give me 1 minute. I'll just. Okay. Can you guys see the question now?
Yes,
No,
yes.
ma'am.
Okay. Okay. Now anybody wants to try?
Ma'am, you can do this slide share so the screen will be open and you will
Um,
be seeing
I'm
everything.
trying. Uh, Teams has this option. I'm not able to find this here.
It is in the lower taskbar where you will see the slide share option.
Yeah. Now you guys can see the question, right?
Yes, ma'am.
Okay. Okay. Now anybody wants to try? Aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of solubilities at pH 6. it's straight away. Aqueous solubility is y-axis shows the aqueous solubility and pH6. So just look at the points, which one is what solubility it is showing, and then rank. And you have to tell them in increasing order.
Obviously, tetracycline is the lowest.
Right, next.
And
Which option would you choose among all these?
what about the first one? Is the first one tetracycline, indomethacin, chlorpromazine, chlorpromazine? Yeah,
Yes,
it's under tetracycline, chlorpromazine, tetracycline.
yes. The answer is first one only. Okay,
Ah,
so this is the tetracycline. This aqueous solubility is lowest. Okay, and then next is indomethacin. Here it will come next, and then at pH 6, chlorpromazine will come. Okay, this one, then this one, and this one. So the answer will be tetracycline, indomethacin, and chlorpromazine. Okay. Now next question. Particles of what size can be excreted by kidneys?
Less than 10 nanometers.
Anyone else?
yeah, less than 10 nanometers.
Yes.
Less than
Yes.
10 nanometers.
Yes, you all are right. It's less than 10 nanometers. If you guys have gone through the lectures, this is the straight answer, less than 10 nanometers. Next question. Next question. Okay. An anti-tubercular drug is administered via two paths, inhalation and intravenous. The alveolar fluid from lungs was collected at different time points. Please explain the large difference in the bioavailability of drugs for the different mode of administration. You guys know what bioavailability is?
It could be third option. The bioavailability of inhalation route is higher for lungs and is hence reflected from the bulk fluid.
Okay. Anyone else? Anybody has any other answer? Okay, yes, you are correct. The bioavailability of inhalation route is higher for lungs and is hence reflected from the bile fluid. This is straight giveaway. This is the inhalation plot for inhalation route, and this is the plot for intravenous. This is the plot for intravenous route, and this is for inhalation route. So via inhalation, there is a higher deposition in the lungs, and it is more bioavailable there as compared to the intravenous, which is not able to go directly to the lungs. Okay, the next question is, which of the following will have higher partition coefficient?
It could be first.
Reason?
I'm not sure, but as a methylene group means that what we can say CH3, CH2, 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 CH2 group means that chain is more long length of that chain is there. So what we can say the lipid content is more, and the
Okay.
formula is lipid to that water, है ना? So that's why I'm not sure.
No, no, you are correct.
Okay,
So this
thank you.
is the partition coefficient equation where drug solubility of drug in oil divided by solubility of drug in water. So more the drug is soluble in oil, higher is the partition coefficient, and it will be soluble more in oil if it is more hydrophobic.
Right.
So more the carbon chains, more hydrophobic it is, and hence more solubility in oil upon water. Okay. Next question. Which two statements are false for partition coefficient?
Third and fourth.
Can you explain why you are choosing those statements?
Because according to the lecture now, that higher the polarity of drug, higher the lipid water partition coefficient. This is true one, right? And here we have been asked to say about the false one.
False.
So,
Yes.
so fourth is because of that. And again here, the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. This is exactly the what we can say, whatever the correct sentence is there. You know? Correct sentence is the second one. So this is exactly the opposite one. That's why.
You are saying second statement is correct.
No, no. Second is correct. According to me, third and fourth is false.
Okay. Anyone else wants to try?
Yeah, I agree. Third and fourth.
Okay.
So third one, as for the fixed law diffusion, probably the transfer will be higher. The more the because of the phospholipid bilayer in the membrane. So third and fourth will be false.
Third and fourth.
Because higher, lower the polarity, higher the lipid water partition. Actually,
That is okay.
that's true, isn't it? So higher the
Yeah.
polarity. Yeah, I think third and fifth,
Okay.
higher the polarity, um, higher the lipid. I think the last third and fifth are false.
Okay. Anyone else? Anyone else wants to try? No one? Hello? You guys can hear me, right?
Yeah,
Hello.
we can.
Okay. Okay, if no one else is interested to answer, then we'll see. Okay. Let's go one by one. Which of the statements are false? So first statement is the ratio of concentrations of a solute in two immiscible liquids when it is in equilibrium across the interface between them. Now only we saw partition coefficient is basically that only. Drug solubility in oil upon drug solubility in water. So the first statement is correct. The next statement is the higher the lipid water coefficient, the greater the rate of transfer across the membrane. So transfer across the membrane is if the molecule is more hydrophobic, the transfer across the membrane will be higher. And higher the lipid water coefficient means more lipid content is there compared to water. It is more hydrophobic. So that's why the greater rate of transfer across the membrane will happen. Now, second option is also correct. The third sentence is the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. Just now we saw the second statement is correct, so obviously this is wrong because higher the lipid water coefficient, more hydrophobic it is, greater rate of transfer will be there across the membrane. So this is one of the false statement. Then next is lower the polarity of drug, higher the lipid water partition coefficient. Polarity of the drug is related to now solubility of the drug in water. So water is polar, polarity of the drug is low, then it is lower solubility in water and higher in lipid. So higher the lipid water partition coefficient. So fourth statement is also correct. Now fifth one is higher the polarity of the drug, higher the lipid water partition coefficient. Since the fourth one is correct, this one is obviously wrong. Higher the polarity of the drug means it is more soluble in water. So higher the lipid, it will be lower lipid water partition coefficient. So the third and fifth statement are false. Here. Okay. Any doubts in this?
No.
Hello? Anyone had any doubt in the previous question? Guys, I can't hear you. Hello?
Yeah, no questions, no questions.
Okay. Which of the next question? Which of the following two statements are true for bioavailability? Just now we saw bioavailability. So anybody wants to volunteer?
Ma'am, last option, bioavailability is considered 100% when the drugs are administered intravenously is correct, ma'am.
Okay.
Second and fourth, correct.
Anyone else?
Second and last option are correct.
Anyone else?
Same, second and last.
Yes, ma'am. Second and last.
Yeah, second and last.
Anyone else wants to answer? Okay. We'll go through the options one by one. It refers to how much drug is available in shops. No. It can be determined by calculating area under the curve by plotting serum concentration of drug over time. Yes, you guys are all correct. It does not depend on route of drug administration. Correct. It refers to the amount of drug that is lost in fast pass metabolism. No. It does not depend on drug physiochemical properties. No. Bioavailability is considered 100% when drugs are administered intravenously. Correct. So you guys all were right. The second and the last option are correct. Okay. Next question. A drug has half-life of 30 minutes in its native form. PEG or polyethylene glycol is conjugated to the drug to improve its pharmacokinetics, and the modified drug is injected intravenously with the initial plasma concentration of 1 mg per ml. After 24 hours, the concentration of drug in serum is 0.5 mg per ml. Calculate the change in the half-life of the drug after modification, assuming first order kinetics of elimination. Report answers in hours. Okay, guys, you have to take pen, paper, and solve. I'll wait for your answers. You guys have gone through the lectures, then you might know first order rate of kinetics of elimination, first order kinetics of elimination. You guys know the equation? Hello? Hello? Do you people know first order kinetics of elimination equation? If you guys know, then only you can solve this problem. Hello?
0.693 upon Ke.
Can you tell me the final answer you are getting? not in this form. Final answer. Anyone got the answer? Did anyone get answer?
Ma'am, you explain.
Okay. So yeah, I have solved it here. Can you guys see this? So the initial drug plasma concentration is C naught. This is the equation we are going to follow, okay? Ct by C naught equals to e to the power minus kt, where k is here rate of elimination and t is half-life. Ct is the plasma concentration at time t and C naught is the initial plasma concentration. So initial drug plasma concentration is 1 mg per ml and the final drug plasma concentration Ct equals to 0.5 mg per ml and time is given here 12 hours. First we have to calculate the T half. First we have to find elimination constant K. Okay, T half here, first time point here is 12 hours. So Ct by C naught equals to e to the power minus Kt, which is Ct here 1 mg per ml 1 by 0.5 equals to e to the power minus K into 12. And then you'll get a final K of K elimination of 0.05775. Then if you want to calculate the half-life, put the same here in the previous equation. Ct equals to 0.56 and C naught, 0.5 C 0.5 will be the half concentration. So we want to calculate the half-life, then the Ct would be 0.5 of initial concentration. That's why here Ct equals to 0.5 C naught upon C naught, which is equals to e to the power minus K elimination rate 0.05775 into T half. And then if you solve this equation, T half will come around 12 hours. Okay? Any doubts here?
No, ma'am.
I can hear only one person. Any doubts? Anyone else? Hello?
No, ma'am.
Okay.
Ma'am,
Yes?
I have one doubt.
Sure.
1 divided by 0.5.
Yeah.
Ma'am, CT is 0.5 na? And C0 is 1.
This should be 2. Yeah, 1 by 0.5 is 2. Wait a minute. Okay, let me redo it. Okay. Uh, this is ln1. CT is 1. 1 by 0.5. Okay. It's 30 minutes. Okay.
मैम LN 0.5 करेक्ट है.
Okay.
Ma'am, if even if we will do
Yes,
it
11.
with
Even if we go
ln2,
ln2, the value will be same.
value will be same. Yes, ma'am.
The answer will be same, 12 hours.
Yes, ma'am.
Okay. We have the next question here. A polymer is made up of the following composition: 10 moles of molecular weight 40,000, 15 moles with molecular weight 45,000, 5 moles with molecular weight 50,000. What is the polydispersity index of the polymer? You guys know the polydispersity index formula? Hello?
Don't know, ma'am. Please give formula.
Okay, polydispersity index formula is mw by mn. Weight average molecular weight upon number average molecular weight. Yes, here. Can you guys see here? It's mw by mn. And mw is weight average molecular weight, which is summation of number of moles into molecular weight square upon summation of number of moles into molecular weight. You have to first calculate mw, and then you also have to calculate mn, which is summation of number of moles into molecular weight upon summation of number of moles. Okay. First, you guys calculate mw and mn and tell me the answer. Polydispersity index is just mw upon mn. Should I share the formula once more?
Yes, ma'am.
Okay. Here it is. Weight average molecular weight, or MW, is summation of NI-MI square by summation of NI-MI, which N is number of moles, M is molecular weight. MW equals to summation of NI-MI square divided by summation of NI-MI. And number average molecular weight is Mn equals to summation of NI-MI upon summation of Ni. N equals to number of moles, M equals to molecular mass. MW equals to summation of NI-MI square by summation of NI-MI, and Mn equals to summation of NI-MI upon summation of Ni. And polydispersity index equals to MW by Mn. Okay, I forgot to inform you guys that this entire session is recorded and it will be uploaded in YouTube for your reference. If anybody of you wants the link, I can share with you guys also. Now back to the question. The polymer is made up of the following composition: 10 moles of molecular weight 40,000, 15 moles of molecular weight 45,000, 5 moles with molecular weight 50,000. What will be the polydispersity index? We'll first calculate the MW or weight average molecular weight, which is summation of NiMi square by summation of NiMi, where Ni is the number of moles and Mi is the molecular weight. Did anyone get an answer for the weight average molecular weight, MW? Yes, Swapnesh Kaparni, please go ahead. Okay. 444 44433. Okay. Anyone else? And what is the Mn, number average molecular weight, which is summation of NiMi by summation of Ni? Okay. Anyone else? Okay, Swapnesh. Anyone else got any answer? I'll wait for 5 more minutes. A polymer is made up of the following composition: 10 moles of molecular weight 40,000, 15 moles with molecular weight 45,000, 5 moles with molecular weight 50,000. For polydispersity index, which is weight average molecular weight upon number average molecular weight, we first have to calculate weight average molecular weight, and the formula is summation of NiMi squared by summation of NiMi, where Ni is the number of moles, Mi is the molecular mass, and Mn is summation of NiMi by summation of Ni.
இது வேற.
Did anyone else get the answer? Hello? Am I audible? Hello?
Yes, ma'am, you're audible.
Okay. Was anyone else able to solve?
Ma'am, I am in commuting, so I won't be able to do the pen work.
Maths. Okay. Okay. Uh, so Swapnesh was correct. The correct answer is 1. And here is the solution. 10 moles of molecular weight, 40,000. And then 15 moles of molecular weight, 45,000. 5 moles with molecular weight, 50,000. So first we'll calculate MW. MW is NiMi square by summation of NiMi. Ni is the number of moles, which is 10, and molecular weight is 40,000, 40,000 square, plus the second one, 15 into 45,000 square, plus 5 into 50,000 square, total divided by 10 into 40,000, 15 into 45,000, plus 5 into 50,000. And you'll get around 44,433.96. Then Mn, which is summation of NiMi by summation of NiMi, which is number of moles, 10 into molecular weight, 40,000, plus 15 into 45,000, plus 5 into 50,000 divided by total number of moles, 10 plus 15 plus 5, which is 44,166. And the final answer would be polydispersity index equals to MW by Mn, which is 1.006. So in your exams like this, there will be a range 0.7 to 1.3. If it's okay if you guys have not got exactly 1, but it should fall within this range to be accepted as a correct answer. Okay. Anyone has any doubt in this question now?
No, ma'am, you can go ahead.
Okay. We'll move on to the next question. This is the last question for the day. Okay. A drug A is injected into a patient. The rate of elimination of A is 25 gram per minute and its plasma concentration is 5 mg per ml. What is the rate of clearance of the drug from the body in liter per minute? Assume that the drug distributes in total body water. A drug A is injected into a patient. The rate of elimination of A is 25 gram per minute and its plasma concentration is 5 mg per ml. What is the rate of clearance of the drug from the body in liter per minute? Okay, someone has solved 5. Okay, anyone else? I'll give you guys a hint. Rate of clearance is rate of elimination upon plasma concentration. Rate of clearance is rate of elimination upon plasma concentration. A drug A is injected into a patient. The rate of elimination of A is 25 gram per minute and its plasma concentration is 5 mg per ml. What is the rate of clearance of the drug from the body in liter per minute? Rate of clearance is rate of elimination upon plasma concentration. Okay, I can see a lot of answers now. Yes, yes, you guys are correct. It's 5 liter per minute. Here is the solution. Rate of elimination 25 gram per minute. Plasma concentration 5 mg per ml. Rate of clearance equals to rate of elimination by plasma concentration, which is 25 gram per minute by 5 mg per ml. You guys have to be very careful about the units. 25 into 10 power 3, we are converting it into mg per minute, and then 5 into 10 to the power 3, this is we are converting the milliliter into liter, mg per liter. Now the final would be 25 by 5, which is 5, and liter per minute. Anyone has any doubt in this problem?
No, ma'am.
Okay. Okay, these were all the questions for today's session. Anyone has any doubt in any of the question that we solved today?
Madam, not with respect to the doubt. So the assignment will questions will revolve around these concepts, fundamental concepts.
Yes, yes. Whatever
Mostly,
he has
mostly.
taught in this entire week, it will all be based on those only.
But these 10 questions will help us solve the problem.
Yes, yes, yes. You
Yeah,
can
yeah.
expect similar kind of questions in your assignment as
All
well.
right, all right. Thank you, madam. Thank you.
Ma'am, we'll be getting this link now.
Sorry?
Can you send the link that you'll be posting on YouTube?
Sure, sure. I'll send you the link. I'll share this PPT also so that you guys have the solution with yourself. Okay.
Thank you, ma'am.
Okay.
Ma'am, it
For
will be emailed.
I'll upload it in a Google Drive and the link will be shared to you guys. You guys can access the link anytime you want.
Okay.
Okay. So we'll go through the questions once more because some of the people joined very late. So and we guys have we guys already have solved all these. So there is no point in uh, asking for answers again. I'll just go through all of them once again. So first concept is based on pharmacokinetics. First question is based on pharmacokinetics. Which two statements are true for pharmacokinetics? Pharmacokinetic studies help in determining dosage regimens. That is correct. Pharmacokinetics helps us understand the drug receptor interaction at the tissue level. No. Pharmacokinetic studies are used to identify new drug targets. No. Pharmacokinetic drugs studies how drugs are absorbed or metabolized throughout the body. Yes. Pharmacokinetic studies how diseases spread in geographical region. No. Pharmacokinetic studies how drug dissolves in water and diffuses in air. No. So the correct answers would be pharmacokinetics or PK studies help in determining dosage regimens, and PK studies how drugs are absorbed or metabolized throughout the body. Okay, so there will be, you guys can expect this multiple option selection, multiple correct answers in the questions for your exams or assignments. So be very careful, study the question, look at the question very carefully, how many statements it says, and select the correct statements. Only then your answer will be accepted. If you're selecting one or not the correct answers, not all the correct answers, then it might not be accepted. So please be very careful while reading the question. The next question is, aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of solubilities at pH 6. So the y-axis shows the aqueous solubility, and at pH 6 we have to see what is the solubility of each of the drug. This is the lowest, which is tetracycline, and then comes indomethacin, and then comes chlorpromazine. So the first option will be correct: tetracycline, indomethacin, chlorpromazine. The next question is, particles of what size can be excreted by kidneys? So this is straight away less than 10 nanometers. Next is, anti-tubercular drug is administered via two paths, inhalation and intravenous. The alveolar fluid from lungs was collected at different time points. Please explain the large difference in the bioavailability of the drugs for the different mode of administration. So this is the inhalation and this is the intravenous. And this is the concentration of the drug. Inhalation route has a higher concentration of drug and intravenous has a lower concentration of drug. So from this we can say the bioavailability of the inhalation route is higher for lungs and is hence reflected from the bowel fluid. So that will be the correct answer. The next question is, which of the following will have higher partition coefficient? Which of the following will have higher partition coefficient? So partition coefficient is basically drug solubility in oil upon drug solubility in water. So we need to check which one of these is more soluble in oil, that will have a higher partition coefficient. So the longer the carbon chain, more soluble it is in oil, or more hydrophobic it is. And here the first option has more number of carbon chains, so this will have a higher partition coefficient. First option is the correct answer. The next question is, which two statements are false for partition coefficient? Again, partition coefficient is drug solubility in oil upon water. So first is the ratio of concentration of a solute in two immiscible liquids when it is in equilibrium across the interface between them, which is basically this. So first statement is correct. The higher the lipid water coefficient, the greater the rate of transfer across the membrane. The rate of transfer across the membrane will be more if there is higher lipid compared to water solubility. So the second option is also correct. Then the third option is, the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. This will be the wrong answer. This is the wrong statement. Then lower the polarity of the drug, higher the lipid water partition coefficient. This is correct. And then higher the polarity of the drug, higher the polarity of the drug, higher the lipid water partition coefficient. This is also wrong. So the two correct answer for this question would be, the higher lipid water partition coefficient has low rate of transfer across the membrane, and the last one, higher the polarity of the drug, higher the lipid water partition coefficient. Next question, which of the following two statements are true for bioavailability? It refers to how much drug is available in shops? No. It can be determined by calculating area under the curve by plotting serum concentration of drug over time? Yes. It does not depend on route of drug administration? Correct. It refers to the amount of drug that is lost in first pass metabolism? No. It does not depend on drug physiochemical properties? No. Bioavailability is considered 100% when drugs are administered intravenously. Correct. So the two correct statements for this question would be, it can be determined by calculating area under the curve by plotting serum concentration of drug over time, and bioavailability is considered 100% when drugs are administered intravenously. The next question, a drug has half-life of 30 minutes in its native form, and then PEG is conjugated to the drug to improve its pharmacokinetics, and the modified drug is injected intravenously with the initial plasma concentration of 1 mg per ml, and then after 12 hours the concentration of drug in serum is 0.5 mg per ml. Calculate the change in half-life of the drug after modification, assuming first order kinetics of elimination. So the first line, which is the drug has half-life of 30 minutes, is not that won't be used in solving the problem. The only thing we need here is the initial plasma concentration, which is 1 mg per ml, time 12 hours, concentration of the drug in serum at time t, which is 0.5 mg per ml. And to solve the problem, first we'll calculate the K elimination, which will come from Ct by C naught equals to e to the power minus Kt. After solving this, you'll get a K value of 0.05775, and for half-life, which is 0.5 C naught upon C naught equals to e to the power minus K elimination we got from the previous, after solving the previous one, into T half. And if you solve the equation, you'll get T half equals to 12 hours. Then a polymer is made up of the following composition: 10 moles of molecular weight 40,000, 15 moles with molecular weight 45,000, 5 moles with molecular weight 50,000. the polydispersity index of the polymer is, that will be polydispersity index equals to summation of equals to mw by mn, which is molecular weight average molecular weight upon number average molecular weight. And you can solve it like this. Okay. Mn is summation of NiMi by summation of Ni. NiMi is number of moles into molecular weight, summation of all the moles into molecular weight divided by number of moles. And then Mw is summation of NiMi square by summation of NiMi. And polydispersity index equals to Mw by Mn. And you'll get a final answer of 1. Last question. A drug A is injected into a patient. The rate of elimination A is 25 gram per minute and its plasma concentration is 5 mg per ml. What is the rate of clearance of the drug from the body in liter per minute? So the rate of clearance is rate of elimination upon the plasma concentration. And you can just simply put the value there and do the conversion, unit conversion, and you'll get an answer of 5 liter per minute. Rate of clearance equals to rate of elimination upon plasma concentration. Okay. Okay, guys. Any questions? Do
No,
we
ma'am.
any doubts? Any questions?
No, ma'am.
Okay.
No, ma'am.
Okay. Okay, then we'll stop here and I'll meet you guys next week. And I'll try to upload, share the YouTube link as well as this PPT that we discussed today uh, via Google Drive. I'll share the links with you. Okay. Bye, everyone.
Bye.
Bye,
Thank
ma'am.
you.
Thank you, ma'am.